In this video lecture, we'll be solving this problem, furthest building you can reach. So we have already solved this problem using priority queue, and I have attached the link to that video in the description below. So make sure to check that out before you move to this approach. So let's take a recap of the problem. In this problem, we're given an integer array representing heights, which are the heights of some buildings and consecutive buildings. We are also given two integers, bricks and ladders, representing the number of bricks that we have and the number of ladders that we have. We start our journey from building number 0. So the buildings are numbered from 0 to n-1. And we move to next building by possibly using either bricks or ladders. So let's say we are standing on building number I. If you want to move to building number I+1, then we need to check if the current building's height is greater than or equal to the next building's height. In that case, we do not need ladder or brick. We just jump to the next building. Otherwise, if the current building's height is less than the next building's height, then either we use one ladder or we use the bricks equal to the difference between the heights of the consecutive buildings. Fine, we have to use our bricks and ladders in the most optimal way such that we can go as much far as we can while jumping over the buildings, and we have to return that index in our solution. So in the input will be given the heights array with n integers representing n heights of the buildings, two integers bricks and ladders representing the number of bricks that we have and the ladders that we have. While in the output we just have to return an integer representing the furthest index where we can reach starting from the index number 0 or building number 0. Let's see the constraints of the problem. The height array may have a length up to 10 raised to the power 5. While the maximum height that any building can have goes up to 10 raised to the power 6. While the number of bricks that we can have may go up to 10 raised to the power 9. While the number of ladders that we can have may go up to the length of the heights array that we have. Fine. So let's better understand the problem statement using an example. So here we have our example. This is our heights array which contains 7 integers. This is the bricks and ladders that we have, and so initially I'm standing on building number 0 and I can jump to building number 1 without using any bricks or ladders because the next building has a lesser height than the building on which I'm standing. So I just jump to the building number 1. Okay, so here I'm standing on building number 1 and now I want to jump on the next building, which is building number 2, using either bricks or ladders. So how many bricks I have to use to jump to building number 2? That is equal to the difference between the height of the second building and the height of the first building, which is 7 minus 2, that is 5. We require 5 bricks and we have 5 bricks to make this move. So we jump to building number. So here I'm standing on building number 2 and I have 0 bricks remaining. So the number of bricks that I have are 0. Then I want to move to building number 3 and I see that the height of the building number 3 is less than the height of the building on which I'm standing. So I jump to building number 3 without using any bricks or ladders. So here I'm standing on building number and I have only, then I want to move to building number 4 and I require 9 minus 6, that is 3 bricks or 1 ladder. In the previous step where we had to use bricks or ladders, I used bricks. So I have 0 bricks at this step. So I cannot use bricks, rather I have to use ladder here. So I use my only ladder which I have and I jump to building number 4. So here I'm standing on building number 4 and at this point I do not have bricks or ladders. Can I jump to building number 5? And the answer is no, because it requires 14 minus 9, which is 5 bricks or 1 ladder. We do not have bricks or ladders here. So just stay at building number 4 and that is the answer. But this answer depends on the choice of the steps that we took. That is, at the second step, while moving from building number 1 to building number 2, I used brick. When I was jumping from building number 3 to building number 4, I used ladder. So this is a choice which I made which set me on an index number 4. But there is another choice. I can either use ladder here and bricks here. That is the second choice. And what would be the final answer if I make this second choice, that is using the ladder first and then bricks? In that case, let's see that. So here I use my ladder on step number second. Then here, that is moving from 3 to 4, I use my bricks. So I had 5 bricks, and how many bricks I need to use to jump from building number 3 to building number 4? That is 9 minus 6, 3. So I use my 3 bricks, and the remaining bricks are 2, and I arrive at index number 4 again. Now, can I jump to index number 5 or building number 5 by using the remaining bricks? And the answer is no, because the bricks that we require to jump to building number 5 are 5, while the bricks that we have are 2. Hence, the answer is not affected by the choice of steps that we make in this particular test case. Hence, the answer is 4. But, so this is a very naive case where the order of steps did not affect the final answer. We do not always have such scenarios. In some test cases, in a more general test case, the final answer is affected by the choices that we make while using our bricks and ladders. So let's try to build a solution for this problem. So this is a heights array. So this is another test case. So let's take this example, and for this example test case, we have 10 bricks and 2 ladders. I want to reach at the furthest index using these bricks and ladder. Let's try to build a solution for the problem. So I can see that for this problem, I have explained a priority queue approach in my previous video, which I will be attaching in the description. So make sure to check that video before you arrive at this video. Fine. So in this video, I'll be discussing about another solution to solve this problem. So what I observe here, so let's define an index I, which is the answer index for this test case. So I is the answer for this test case. That is, we can arrive at ith building using our bricks and ladders in the most optimal way. Then I cannot reach the indices which are after the index number I. That is I plus 1, I plus 2, and so on till n minus 1. They are unapproachable. Fine. While the indices which are before this index I are always approachable. That is index number I minus 1. We can reach these indices. I can reach index number I minus 2, and so on till 0. So what do we observe here? We can observe a monotonicity in the behavior of the indices. So these are indices. I can see a monotonicity or a monotonic behavior. That means let's define a predicate function. So let's define this. So let's define a predicate function and call it is approachable, which takes in an index of this array, heights array, and it returns a boolean variable, either true or false, which represents whether the index number I, which I am passing as an argument, is approachable or not. Fine. So for all these indices from 0 to I, this function will return true, while for all the indices which are after this index number I, this function will return false. So what do I observe here? I observe a monotonic behavior here. Fine. So what is the target? Our target is to find this index I, or let's say this is the resultant array for this function, this predicate or boolean function. Now the task is reduced to find the position in this array which contains this last true. Fine. So how can I solve this problem? So we know that we can use a binary search for this type of problem. Whenever we find a monotonicity, we can use binary search. So here I can use the binary search, or more precisely, this technique is called binary search on answer. Fine. So this is my array, boolean array. So I'm binary searching on the indices. What I'm doing, I'm just defining a left bound on the starting index, which is 0, and the right bound on the ending index, which is 8. I find the middle index, which is 0 plus 8 by 2, which is 4. I put this index into this my is approachable function. If it returns true, that means our target index lies in this range starting from 4 till 8. It can either be 4 or some index after 4. Because this is a valid index, I can reach index 4. Then the range is reduced to 4 to 8. Here I again find its middle element, which is 4 plus 8 by 2, which is 6. So I check at index number 6, which is this, and this is not approachable. That means the target index lies in this range, that is from 4 to 6. 6 is excluded. 6, and I again find my middle index, which is 6 plus 4 by 2, which will give me 5, and for 5 I have true. Then I say, okay, the answer lies in this range from 4 to 5. The low contains 4 and the high contains 5. I again find the middle index, which is 4. So I check at 4. It again returns true. So the range is reduced to 5, 5. low is at 5 and high is at 5. That means low becomes equal to high at this point. The range shrinks. So this low will contain our answer, and the answer is 5. So 5 would be the answer for this test case, and that is true. We can arrive at index number 5. Here I just assumed that the answer is index number 5. Actually the answer is index number 7 for this particular test case. I just took 5 just to explain the algorithm. Fine. So the answer for this test case would be this index I. I've got the index using my approach. So all I want to do now is to find the definition for this is approachable function. How would I check if the particular index which I have passed is approachable or not? That's the challenging part of this problem. Okay, so this is my is approachable function, and this is the heights array on which I want to define this predicate function. See how we can do that. We know that an index I is approachable if given some bricks and ladders. I can use them optimally to arrive at that index. So how do we use the bricks and ladders optimally? So let's say we have arrived at position number I, and I want to jump to position number I plus 1 here. How many bricks I require? The bricks I require are 18 minus 3, which is 15. So I require 15 bricks or one ladder. So that is the choice I have to make at every step where I require either bricks or ladder. And the optimal choice for this case would always be to use the ladder for that case which require the maximum number of bricks. So till some position I'm just jumping to position number I plus 1, and it requires 15 bricks or one ladder, and I have these 15 bricks. What I would do, I will check for all the previous steps which I have taken, or I will find the maximum difference till I, or in other words the maximum difference between two consecutive buildings, and I will compare that difference with the bricks which I am using here. If that difference is greater than the bricks which I am using here, then instead of using the ladder at this position, I will use the ladder for that. Okay, so let's say we're given some B bricks and L ladders, and I want to arrive at the farthest index in this array. And let's say I'm standing at index number I, and I want to jump to index number I plus 1. I require 18 minus 3, which is 15 bricks or one ladder. What would I choose? And here at this position, let's say we do not have enough bricks to use. I can just use a ladder. So what I would do? So here the optimal step that we took even in my previous video, just check for the maximum difference between the two consecutive heights till, let's call it D. So D is the maximum difference between the consecutive heights till I reach index number I. And I will compare this difference with the number of bricks which I require for this step. And if this difference D is greater than these number of bricks, then that means it is optimal to use ladder at this position and bricks for this position, because in that choice I will consume lesser number of bricks. So at the end of the day, I'm just optimizing the number of bricks which I use till any index I. So that's my target. So I arrive at any index, check the bricks which I require to jump to next index, find the maximum bricks that I have used till now, and make the move optimal. So that means, so in this way, I will end up using the ladders for those indices which require maximum number of bricks, and I will end up using the bricks for those indices which require minimum number of bricks. So that's the final configuration which I require. So how would I solve this problem? So how this fact can help us define our is approachable function. So let's say I pass some index I in this is approachable function. How would I know if I can approach this index or not? I can arrive at this index or not? All I would do, I'll just find the consecutive differences of the buildings till I. That would be 14 minus 4, which is 8, 2 minus 12, which is minus 10, 7 minus, only positive differences I will store, because I don't require bricks or ladders to jump to a smaller building. Difference between these two heights, 7 minus 2 would be 5, and that's all. And I will sort these values in the decreasing order. So let's say I pass some index I in this is approachable function. I want to know if I can reach that index or not. So what I would do, I will find the consecutive differences till I, the positive differences, because there's no meaning in storing negative differences, because I don't require ladder or bricks to jump to a smaller building. So let's store the positive differences. 12 minus 4 would give me 8. Then 7 minus 2 would give me 5. 18 minus 3 would give me 15. 20 minus 18 would give me 2. So these are the differences which I have, or the jumps which I have to make. So what is the optimal move? Optimal move would be to use the ladder for those jumps which require maximum number of bricks. First priority would be for this 15. Second priority would be for this 8. Like priority of using ladder, and so on. So in that case, I will sort this array in decreasing order of values. That would give me 15, 8, 5. Then I will iterate over this array and I will start using my ladders. So let's say I have 2 ladders or 10 bricks. Then I use ladder for this step which require 15 bricks. The ladder becomes, the remaining ladder is 1. Then I use ladder for this difference, that is 8. The ladders go 0. Then I use bricks for this. Then I use bricks for this. The remaining bricks are. So this is the most optimal step in this case. I am using the ladders for those steps which require maximum number of bricks. Right? Very simple. So that's how I define my isApproachable function, or let's call it check function. You can also call it check function. It will check if a particular index can be approached or not. All I have to do, store the positive consecutive differences, sort them in decreasing order, and use the ladders and bricks in the order I explained here. First use ladders, then use bricks, and at the end check if I can cover all these differences. So in this particular array, I can cover all these jumps, hence I can reach index. So this index is approachable. If I cannot cover all these differences using the given ladders and bricks, then I will return false for that index. Fine. So let's see the implementation of the idea which I explained here. So this is the furthest building function which takes in the heights array, the number of bricks and the number of ladders. Calculate the size of the heights. Initialize 2 pointers for performing binary search for the starting index and the ending index of this heights array. Perform the binary index, and here for any index which I am calculating, so I calculate the middle index. I check if that index is approachable. If it is the case, then the search space reduced to mid, from mid to high. Otherwise the search space is reduced to low to mid -1. Fine. Let's see. Finally, this low variable will store my answer. So this is a simple binary search on answer which I am performing. If you're not getting this strategy, I would recommend you to go to the blog which I will link in the description for the binary search on monotonous functions. So learn about that and then come back to this video. So let's see the definition of this check function. So here's the definition for this check function, which takes in the heights array, the bricks, the ladders, and the index. So I want to validate if this index is approachable or not. I declare a difference array. I iterate over the heights array starting from the second index till this middle index, and I store all the positive differences. If the height of ith building is greater than the height of its previous building, then that will give me a positive result, and hence I will store the difference. Finally, I sort the differences in the decreasing order, and I will simply iterate over the, and then okay, so I iterate over the difference array. So here I'm starting to iterate over the difference array from the ladders variable. Why? Because till index ladders -1 in the difference array, I've already used my ladders, and for the next indices starting from the ladders till the last index, I'll have to use the bricks. And I check, and here I'm checking if the difference for any particular index is greater than the bricks available. If that's the case, I'll return false from here. Otherwise, I will use those bricks from the stock of the bricks available and continue to the next. Finally, if I end up successfully running this loop till the last index, I'll return true, right? Fine. So that's the implementation of this idea. Let's discuss the time and space complexity. So you can see that I'm performing a binary search. So I'm performing a binary search, which I know that takes big log of n time complexity. And here I'm checking this index. I'm calling this check function for log n time, because that's the number of indices I visit in binary search. So what is that complexity of this check function? So we know that in this function, I can check for, let's say, nth index, n minus 1th index, and this loop iterate over all the indices from the first index till the index I am checking, which may go up to big of n, which may go up to the last index, which will give me the time complexity of big of. So that is the time complexity for this function, which will give me the final time complexity of n multiplied by log n. So that's the time complexity for the solution for the binary search solution. While the space complexity is linear. Why? Because I'm using a difference array to store the differences of the heights in my check function. So let's see the code implementation of the solution which I explained. Okay, so this is my solution class. We have two functions, check function and furthest building function. The furthest building function takes in the height, the bricks and the ladders. So first convert the size of the heights array. Then I define two pointers for the starting index and for the ending. Then I run my binary search over this range and this is the normal binary search on answer, and here I am calling this check function. Finally, the low variable will contain the answer and I will return that low variable right at the end of the function. So let's define the check. So here I define a difference array and I store the positive differences of consecutive heights into this difference array. Then I sort them in decreasing order and I simply skip the indices in the difference array till ladders -1, because for those indices, for those differences, I'm using ladders available to me. Then I will start using bricks, and if I end up exhausting my bricks in between, then I return false from there, because it is not possible to cover all the differences using the bricks and ladders. Otherwise, I'll return true at the end of this. This is how this check function is working, and this is the final solution coded in C++. Let's see the solution in other language. So this is the implementation in Java, and this is the implementation in Python language. So that's all for this video. If you like the video, then hit the like button and make sure to subscribe to my YouTube channel and give your feedback in the comments below. I'll see you in the next video. Till then, take care. Bye bye.